Welcome back, everyone. Today we are going to be proving the difference of cosine sum to product identity, which is shown right here. Okay, so the first thing I'm going to do to prove this is we're actually going to define some new variables here. Let's let c be equal to a plus b divided by 2. And let's also let d be equal to a minus b divided by 2. And the reason I've chosen these specifically is because over here, we have sine of a plus b divided by 2. In here, we have sine of a minus b divided by 2. All right, so now I'm going to solve both of these in terms of a. So I'm going to multiply 2 to both sides to get that 2c is equal to a plus b. That means that a is equal to 2c minus b. Then over here, same sort of idea here. I'm just going to multiply by 2 and get 2d is equal to a minus b. That means a is equal to 2d plus b. All right, now let's let this be equation 1 and this be equation 2. Let's add these together. And we're going to get a plus a, which is 2a on the left. And then on the right, we're going to get 2c minus b plus 2d minus b. And now I'm just going to cancel out the plus b and minus b and divide both sides by 2 and get that a is equal to c plus d. Okay, now let's do the same thing, but this time we're going to find b in terms of c and d. Okay, so to do that, I'm going to go back to over here and say, therefore, b is equal to 2c minus a. And also from this equation right here, we know that b is equal to a minus 2d, like that. And then I'm going to add up these equations. We'll label them 3 and 4. Equation 3 plus equation 4 is going to be equal to 2b on the left, and on the right, 2c minus a plus a minus 2d. So then again, if we cancel those a's, we end up with 2b is equal to 2c minus 2d. And then if we divide by 2, we get that b is equal to c minus d. And so these two right here, these are our key equations we're going to use. We found a and b with respect to the c and d that we defined earlier. Okay, so next thing we're going to do is we're going to start with the left side and then derive the right side using this. So on the left side, we have cosine A minus cosine B. So let's write that out. Cosine A minus cosine B. Well, according to this, that is going to be equal to cosine of C plus D minus cosine of C minus D, like that, right? Because essentially all I'm doing here is I am replacing A with C plus D and B with C minus D. And then if we use the sum and difference formulas, we get cos C, cos D, minus sine C, sine D, minus cos C, cos D, plus sine C, sine D. Okay, now we're going to remember that when we have minus cosine C minus D, that means we need to use the distributive property and distribute this negative sign, which we treat as a -1, into both cos C, cos D, and sine C, sine D. And so this becomes, I'm just going to copy this, cos C, cos D, minus sine C, sine D, minus cos C cos D, and then minus a positive is going to be another negative as well. So minus sine C sine D. A common mistake I see here is forgetting to distribute that negative sign throughout both cos C cos D and sine C sine D. Okay, now these cancel out. These are just opposites, right? The one's positive, one's negative, but otherwise they're the same thing. And so we end up with -2 sine C sine D when we put these together. And then if we recall from earlier we said that C is equal to A plus B over 2, and D is equal to A minus B over 2. So that means negative 2 sine C sine D is the same thing as negative 2 sine C, which is A plus B over 2, right? Minus, and then times sine D, which D is A minus B over 2, like that. And there we go. And as you can see, that is exactly the identity that we had set out to prove. If you have any questions, please feel free to put those in the comment section, and we'll see you for the next one.